In this video, let's try to get an intuitive idea of what inflection points are. I think you might have already done some problems, or at least seen some problems about finding the inflection points. But in this video, we're just going to get an idea of where the procedure to solve all those problems comes from. Okay, in another video, we'll go through a problem and we'll refer back to this as well, so it makes a lot more sense. Okay, so let's start with an example because it'll make it easier to understand. Here's the graph of a function. And here is the point of inflection. I'm telling you that this is the point of inflection. And to find the point of inflection, we have to use tangents to help us. So here's a tangent to the graph at some random point. Don't worry about why I picked this point. Don't worry about what the tangent is. Don't worry about what that point is or anything like that. I'm just telling you this is the tangent to the graph. Okay? What I want to show you that's more important is an animation showing how the tangents, showing multiple tangents to this graph as we move along the graph. So what we're doing in this animation here is we basically plotting tangents to many different points along this graph. Okay? What I want you to notice is how the tangent changes from being above the graph to being below the graph. And the other thing I want you to notice is that all along here, the tangent sits above the graph. And then all along here, the tangent sits below the graph. And, most importantly, right in the middle, where this change occurs, that is where the inflection point sits. Now, we have some basic idea of what the inflection point is, but we can't really find what it is just using graphs. We need to use math. And the way we do that is we use derivatives. Okay, again, we're going to see why we have to use derivatives and why we actually use derivatives before we see how to use them. So, remember, just in that animation we saw before, that in order to find the inflection points, we had to use tangents to give us an idea. Okay? In order to find, and you might remember from previous studies that the tangents are related to derivatives. So it kind of makes sense that trying to find inflection points would have something to do with using derivatives. So it kind of makes sense. But you're probably wondering, what is the relevance to the second derivative? Now, to understand that, again, to understand why it's relevant to the second derivative, we have to understand that derivatives are all about change. For example, if we had a function here, and we found its first derivative, then this first derivative actually describes how the original function changes. I'm not going to prove that, because it's going to take us way off track, but if you want to know more, I can make another video. The basic point is derivatives describe change in something, change in functions, right? So if the first derivative describes how the original function changes, then the second derivative will describe how the first derivative changes. Let's look at that again. Here's our function. Let's take the first derivative of that function, which gives us the change of the function. And then let's take the derivative of the function, which will give us the change of the function, which is the same as saying taking the second derivative. So going back over things again, we wanted to find the inflection points. And to do that, we needed to find the change in the tangents. In other words, we wanted the change in the first derivative. In other words, we wanted the derivative of the first derivative. and in other words, we wanted the second derivative. And that's a basic idea of why we need to find second derivatives for inflection points. Next, we'll actually go through a problem, and we'll see how all of this actually makes sense. And we'll go through the procedure of actually solving problems.